Okay, thank you. Hello, this is Eugene, and I have working for bridge and tunnel product in Bentley System Korea. I usually like to say thanks all of you to join this webinar for custom bridge modeling using parametric and functional component. Before give you this presentation, I usually like to introduce the topic and schedule for custom substructure in bridge. This webinar consists of 4 sessions for the parametric modeling. I will explain the basic concept of parametric model with a user case study and how and when to use it in Chapter 1. In Chapter 2, I'm going to explain more detail how to create the parametric model using constraint and variable name in OpenBridge Modeler. And I will let you know how to create custom pier and custom abutment using functional component in remaining chapter. This is the first topic. I'm going to show you when and how to use functional component in bridge. I want to represent the major word regarding functional component and parametric model. The functional component represented the constraint to handle the geometry movements and variable name to control size of a shape using dimensions. And equals parametric model that created by constraint and variable names. Also, I don't want to detail explain for the individual function of constraint in this chapter because I will explain more detail on July 25. The traditional beam model supposed to know the correct dimension and shape to create a 3D model. The pain points are the engineer needed work to create it if the substructure had to change the geometry. For instance, you created this pier using traditional method, and it might be used to potential project, but the geometry had to modified by manually or needed recreated to apply another project. The design circumstance and condition had changed and developing rapidly. Also, engineer needed to reduce design man-hour and keep the due date. Parametric modeling will help you to reduce design cost and time effectively, because the geometry in parametric model will adjust by variable name. I might have had good memories to enjoy with the toy blocks, but sometimes I want to make this a little bigger. So I had to buy new one. I go back to bridge engineering. The model can be modified directly using variable names if the model have to be changed. Because you can see this function in Bentley design tool like MicroStation, OpenBridge, and OpenLoad Designer to assign the constraint and variable dimension to the model. This feature will help you to handle the geometry more easily. Additionally, the bridge in this picture is a bridge in Germany. The surface of bridge was painted in toy block shape and color. We needed some preparation before create a parametric model. The first step needs naming plan to create a variable dimensions, because the major words in bridge engineering are different to each nations or region. For example, some engineer calls the wall as a wall or stem. Also, the external variable to assign dimension and internal variable to calculate formula are required. Finally, needs the work point or base point because we have to know where to move over the structure dimension from base point. Whether the shear key is generated according to back pier slope, I'm going to show you how to create a semi-gravity retaining wall using functional component. And I'm going to change ACS plan to create a 2D profile onto XY plan. Move the variable to specify name and types. But I will import it from existing Excel file. The variable name for input value and calculated value were defined in Excel.csv file, and this file imported to use in OpenBridge Modeler. I will create 2D profile for putting with the shell key. The lines are supposed to connect it because the solid element extruded from area element. Assign the constraint properly. Specify base point for putting. And a perpendicular to the putting height. And specify the angle to the model for the putting with the shell key and without it. Also, the distance type of our alignment should be true because the line distance will change along with the angle. I made a variable name that can have the value true or false to define whether or not the shell key is generated. Assign the distance for putting width and height. It's most important to verify the movement due to each variable names when you finish to assign the name to the component. And assign the distance from putting toe to shell key. each step you have to verify with the variable name and value. And move the putting to the profile to the working point, because the movement of dimensions moves from the working point. And to final review for the movement, putting width, and putting height, and then putting bottom toe width, and change the back pair. All is good. And create a 2D file post temp. Remove existing text on putting because it assigned to verify putting movement. And assemble the putting and stem using coincident. And assign working point for consolidate model. Assign the distance to determine the stem location from front of putting. Width of stem. And assign stem height. Modify the top of stem using counterpoint to specify front of stem slope. And you have to select the dimension alignment type as drawing for this dimension. Define stem top of width. I have some mistake to specify stem height. So I just modify the alignment type for stem height to drawing. Finally, verify the expected movement due to the variable names. And also, you can turn off the dimension and constraint mark. And change the putting key width, the shear key height, and modify the putting width. and height. All of variable name have to verify it by yourself. Change the slope and stem top width and bottom also. And stem height. And then the important point is here, the stem height is moving from top of footing. This is an important point. And I will explain the parametric modeling workflow through Culvert modeling. The first step is create a 2D sketch for this model and apply constraint to the profile. The next step is create a 3D parametric element using 2D profile and modify the 3D element using handle or changing the parameter. Apply variable driven feature to create a complex design component. Verify or change working unit on setting. Before create a 2D profile. The next step is change ACS plan to XY. Because 3D model will extrude that is parallel to the load element or structural longitudinal axis. And create a 2D profile for external and inner section. And modify edge of section for hunch. We just put in the dummy value for hunch. Defined base or working point. All of thickness will parallel to inner box geometry. So that's why I just specify parallel. Create a local variable lane for external width. And height. Then assign this name to the profile. and add width and height for inner box. And then define the dimension to the profile. Add variable name for hunch. And then assign to the profile. And then you can see some alignment here, alignment method. This is a drawing. This is true. And adding the other variable name for bottom slab thickness. And then outer wall thickness. And inner wall thickness. And then assign this variable name to the profile. And I'm gonna create an integer variable name for adjust the number of inner box. And make the other internal variable that will use it to 3D extrusion to specify number of inner box. And modified the variable names so that the external width can be automatically adjusted by number of inner box. if you are define like this display type to hidden, and then the variable will not showing in the cell. If you modify display to hidden and modify the remainder variable so that the distance can be automatically adjusted. And extrude the 2D profile in 3D. And subtracted the inner box volume from the total volume. Specify 3D array for the inner box. And finally, make sure that it changed to the expected shape due to each variable length. Change the number of boxes. And then Culvert height. Inner box height. And width, modified width. Modify the bottom slab thickness. And hunch, modify the hunch. And Culvert length. This is a partial model for Piers, and it will be used to substructure. Create guideline for steel beam to define working point. Will be used to global model. Create a guideline for XY plan. And then connect the line using some constant. And then specify working point for steel beam. And I will attach to the profile as a reference. And copy the section to OpenBrush Modeler because some manufacturing companies has provided to the CAD drawing for steel beams. And you can confirm disconnected line. So I will make it to area element before assign constraint. In order to register the steel section to the library, go to Item Types, create an item library for HP section. And add a new item name. Then add a property definition for section dimensions. I just modify the type is number and define the working unit. And then rename for each dimensions. And modified active value for this section. And copy existing item name to make another one. Then modify the name. And variable value, value. And I want to import remainder section property from existing file. So select import, then choose the DGM file, and you can see imported section items. Move to Constraint tab to define constraint. Assign parallel for this section. I'm already represented you. This model is local modeling. So this modeling will place to the global model based on guideline. So assign the constraint on this section and select a variable, then select item type to take the dimension from the library. And you can also assign the variable name to the section. I'm assigning constraint using equal because this section is a symmetric section for B actual. Assign web thickness and plane thickness. And also you can assign the radius. And move this section to guideline. And assign equal distance to adjust the center of section per working point. And verify the movement by section items. You can turn on the mark. And I'm going to show you the user case. It could be difficult to difficult develop or design tool by all requirements for bridge engineer. This is one of the reasons why I would like to give you this presentation to help you for bridge design using parametric models more easily. This abutment created for Texas DOT. The most difficult challenge was to apply various shape of corner block to a model. The corner block shape had to be changed by condition where bridge skew angle was 0, more than 0 to 15 below, 15 to 25 below, 25 to 45 below, and more than 45 degree. And then you can see each different shape due to skew angle. The abutment putting end were parallel to the bridge skew angle. And also, pile arrangement can adjusted by expected shape of putting. You can change the bagel length and height. The elevation of footing and fire is automatically adjusted by the stem wall height correction. And it allows you can change number of fires. This is the wall pier, and then you will be able to define the ship elevation for the left and right roadway. This model allows you can change bridge bearing seat width and thickness also. You can also select footing type for isolated footing or pile cap. And number of fire and embedded lengths can be changed. This is a pile band. Not only the shape of file band, but also center of file band can be changed from working point. Using some horizontal offset. And the Pier model was created for Composite section, and also you can change number of file and file length. The concrete file will activate in order to confirm the HP pile volume is subtracted. And when you change the HP pile name, then concrete volume of file will be automatically updated. This pylon modeling for ED bridge, but I would like to reuse this model for cable-stayed bridge also, so that I create this model with a functional component. You can change external radius, pylon height, and pylon slope. and change the pylon bottom width. And section length to the bridge axis. Change the cross-gutter hunch size. You can also change the geometry of footing. In this slide, you can see how to create a parametric cell, because reuse the completed model by placing it in another design as a parametric cell. Create a new cell to associate the pile path for bridge template. Define cell origin, but it might not affect to place the model in OBM, because the coordinate 0, 0, 0 of this cell is used as a working point. And change top view and select the model. And specify name and change the cell type to parametric. I'm creating the Piers cell. I created the two cell of Piers, and how to the tag and variable mapping will affect to the result in bridge model. Open a file. To assign tag and variable mapping in OpenBridge Designer. And assign tag to each component, cap, column, and footing and pile. And verified each tags using identify tool. Finally, coffin width will map to cap length. I'm going to place two piers in OpenBridge. Select pier template, place pier. Pier 1 is without tag, and pier 2 assigned the tag and variable mapping. and select Pier 2. Select the support line to place this pier. Move to Assign and Report tab to compare the result between Pier 1 and Pier 2. On Generated Report, you can see the separated quantity of Pier 2 component by tag. And select cap length adjustment to adjust cap length by create deck width. But Pier 1 didn't adjust the cap length automatically because I didn't variable map to this cell. And also, you can change the dimension value into Open model. You were able to understand how tag and variable mapping affect to the result in OpenBridge Designer.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.